So what we will learn today, we will learn some new ideas. Okay. So the very first thing we will learn is regarding the inner class. Let's see where that example. Oh, okay. So on our course website, the example is inner app. There are two files, okay, two Java files, car parts and inner app.java. So let's take a look. So first, let's take a look at this car parts class. So this car parts class, if you take a close look, looks like this is instance variable. So private, nothing new, is it? Factory ID is static, so this is a class variable. So nothing new here, is it? Okay, then let's scroll down to see. Let's just see. Then for this car parts, then what we have its constructor. And the constructor just has single argument, is it? It's assigned this argument to its instance variable, is it? Okay, but if you take a look, there's something else. Okay, so what are those? Let's first take a look at this. If you take a close look, you will find this will A. It's also defined as a public class. But this public class, it's within the car parts, curly brackets, is it? So this is defined within car parts, is it? So this class is called a inner class. So not like a car parts. Car parts is not dependent on any class. It's its own, is it? But this will A is part of this car parts class. So that's why it is called an inner class. Okay, it is an inner class, is it? So it has its own instance variable X. And here, this is what? This is its constructor, is it? And it directly assign 100 to its instance variable, is it? And then let's see, over here, so regarding this will A inner class, so now we are inside this inner class, okay? And we are in its constructor. In constructor, first thing we do is assign a value to its instance variable. And then over here, we try to output something. Output what? Factory ID. Factory ID is what? It is outer classes, class variable, is it? So then looks like it's okay, is it? So looks like inner class allows to access outer class, it's a class variable. Okay, so that's, you can directly access. Then take a look at the third output. Third output, it directly output what? Outer classes, instance variable. So this inner class can access its class variable, and its instance variable of its outer class. And you can also write like this. You can also mention outer class's name. And then dot, then this, then dot, then it's a class variable. Same thing for its instance variable. You can also do the outer class name and then dot this, then dot ID. Okay. So you can directly access. You can also use the outer class's name, then dot this dot to access outer class for an inner class. Okay. Okay, so this is pretty simple one, is it? And next, let's see. This time, this class is a static class. Okay, the class is a static class. And this we call it a static nested class. It's also within the car parts. Okay, and its name is called wheel. And here we have a constructor, is it? Okay, for this one, did you see it can directly access its outer class's class variable, is it? So that's class variable because it's also static, is it? So it can directly access it. Okay, but be careful, okay? If you try do like this, that won't work. Okay, so if suppose I try to comment out system.out, is it with a static wheel nested class car parts factory ID. If you recall, for the previous one, you can directly ask, but this time it's squiggly arrow message. Is it? This time you cannot access outer class. So you cannot use outer class this to access the class variable, the static variable. Okay. Because what? Because it says static nested class doesn't require an instance of outer class. Because it doesn't require to create an instance outer class, so there is no reference of outer class exists, like with outer class dot this. Is it? Because that this, if you recall, it's reference to object itself. But here you don't need. So there is no instance, is it? So you cannot do that this. That's why here it's report error. Okay. So if your class, we also call this nested class because it's embedded within another class. So nested static class, then it cannot access outer class's static variable using outer class, then that's this. It won't allow that, okay? So that's wrong. Okay, then let's get this back. Then let's see if this case is okay. If you take a close look, I'm trying to access outer class, this instance variable. but you see, it's also report error. Okay, it says then it cannot access the outer class non-static instance variable because that ID is non-static. So basically, it can only access. So if your nested class is a static one, it can only access outer class's static variable. Okay, instance variable, the non-static one, it cannot access. Okay, so always keep this in mind. Okay, then we need to comment this out. Okay, and then for will A, if you recall, this is just an inner class. Is it? It's an inner class, so it's within this car parts. So here you want to create an object, you can directly do new will A. Is it? And you can also directly access its instance variable. Is it? X. And then let's see. This is will A class. And X is what? It's private. It's private, but did you see? We also directly access it. Is it? So outer class can still access its private inner class's instance variable. Okay, so this is fine. Okay, and then next, let's see the driver. Okay, so for this driver, then you see first we create a car parts. So this is pretty standard as we already learned. Okay, then let's see this variable. So this variable, the type is what? Is that inner class? And here you can direct it because it's public. Is it public inner class? Is it public inner class? So how do you access? You do outer class, then dot, then inner class. Okay, and how do you create an instance of an inner class? Then you need to do the outer class. So over here is what? So this is an instance of outer class. Is it the car part, the outer class instance? Then you do dot, then new will A. Okay, so this is for non-static inner class. If you want to create an instance outside of the outer class. Previously, in that car part, we see you directly do new will A. Is it? That's within that. This is outside. Outside, then you need to have an instance first of outer class. Then you do new, then you create an object of will A. Okay, then this is an object of will A. Okay, be careful. And it's under an instance of outer class. And then let's see this variable. This variable, the type is what? The static nested class. Is it static nested class? And how do we do it? We do new car parts, then that will. Okay, so this is for static. Then there is no instance of outer class needed. Okay, so it's just go directly to the nested static class. Okay, there is no outer class instance. Okay, so be careful. Okay, so that's a general idea about inner class, nested class. So let's take a look at the running result of this example, okay? So here is a running result, is it? And the output, the car parts object created, then the respective information, is it? And over here, okay. Okay, so this is regarding inner class. And then what next? Let's see this example. And the next example of our course website, it's called Hello World Anonymous Classes. Okay, that example. Anonymous, let's take a look at this one, okay. For this example, let's take a look. So here we have a class called Hello World Anonymous Classes. It's a public class. And within it, so you can also nest interface within a class. That's also allowed, is it? So here we define a Hello World interface. Okay, interface. So this is an interface, Hello World. And the interface just provide method prototype, is it? So those are abstract methods. So just a frame. There is no implementation. Okay, so this Hello World has two methods, great and great someone, is it? But be careful, this is what? An interface, okay, an interface. Okay, then next, let's see. So for this Hello World Anonymous classes, we define a method. Is it called see hello? For this method, let's see. Within this method, you define a class. So we already learned, is it? So basically, this is an inner class because you define it within an outer class. So this is an inner class. But this class, it does what? It implements that Hello World interface. Is it? Okay, so nothing new here. So anyway, this is just an instance variable name. Is it? Then it implement those two abstract methods. So over here, it implements the two abstract methods. Is it? Of the interface. Okay, for grade. Okay, it's just called grade someone. Okay, grade someone, it's going to assign name from the parameter and then output hello someone. Is it? So anyway, so this is an inner class, and this inner class has a name. And the name is called what? English grading. Is it? Okay, because it's an inner class, then what I do is I use it to create an object. Is it? So this English, so over here to create an instance of English grading. Okay, to create an instance, then it assign to this variable. The variable type is what? Is that interface. Is it? This is fine. Previously, if you recall, we learned polymorphism. Is it? So that is fine. You can do this. Okay. And then, so English grading, then we don't have any issue, is it? And then for English greeting, then you can call that greet method. Is it? Because we already implemented it. Okay, then next, let's see the second one. This French greeting, this is a variable. The variable type is interface. So that is fine, is it? And then over here is just called new hello world. What is this hello world? This hello world is an interface. But if you recall, an interface cannot be used to serve as a constructor, then to create an object. So then what is this? Is it basically, if you recall, whenever you do new, after it should be some concrete class. Is it? It should be a concrete class name. Is it? So basically, and then parameter. So this means you call concrete class constructor. You call the constructor, is it? But here, what is this? Is it? This is very weird, is it? If we compare this one and this one, and over here, this one. Okay, let's see. Over here, you define a named inner class, is it? And this named inner class, it also implements an interface, is it? And that has its method, is it? It has a method. And basically, the constructor is a default one, as it didn't provide. That means it has the English greeting. Is it? It's just not implemented, as it's by default. Okay, and then with this named inner class, so basically this is, it also implement the abstract methods. As it, so basically this class is a concrete class. It is a concrete class. Because it's a concrete class, that's why you create an instance. An instance of a concrete class. So over here, then basically this new, it's equivalent to somewhere we also define a class, kind of called class French greeting, and then implements hello world. Okay, and then later on over here, it do that new French greeting. Okay, French greeting. And if we compare these two, we will find this part is crossed out, is it? And this part also crossed out. And this part, the curly brackets part, we keep. The curly brackets part we keep. And we also keep this new. Is it? And we cross out this and replace this with that hello world interface. So basically, this is equivalent to you write of this. It's just an abbreviated version, is it? But of course, over here, you didn't define a named inner class. We didn't, is it? There is no name, not like this. This inner class has a name. Is it? Over here, there is no name. Is it? Okay, so this is a new concept. If you do something like this, new, following that is an interface name. And then parentheses, kind of like you do the constructor, but you still have the complete class implementation body. Those parts, you still have that. We didn't ignore them. Okay, so basically, this is equivalent to we define a class without a name. And at the same time, we also create an instance of this class. It's kind of you just write a single statement, but you do all of that. So this kind of situation, we call it anonymous class, because there is no name, is it? And then just think about anonymous class can only be used once, because there is not like this, is it? You have the English class, then you can use it to create multiple instances. Is it not a thing? You can use it more than once. Is it more times? Okay, repeatedly use. Not like this one. This one, after you do this new hello world, there is no way to redo again. Is it with the, if you don't want to write off the implementation, there is no way. So that's anonymous, that can only be used once. Okay. But basically, keep this in mind. Basically, this whole part is just an assignment statement. Is it? This is a single statement. Is it? But within it, basically it's what? This part is class implementation. Is it? So within the curly brackets, you still fully implement the class. Okay, fully implement the class. Be careful here. Okay, so this case we call it anonymous class. And anonymous class, a lot of time, because in a lot of applications, you just use it once. Okay, you're not going to repeatedly use. but then it saves a lot of work for you to define a class, a named one, and then create an instance. It's kind of you take away part of the code, but just keep the implementation part. Okay, then in this case, we call it a anonymous class. And then let's see. The next one, for the Spanish greeting, it's the same. Is it? It's anonymous class again. And in this case, it's anonymous inner class. Okay, anonymous inner class. So no class name, it's always new something. This something can be interface. It can also be some superclass. Okay, and then parentheses. So here is the implementation of class. Basically, implementation of class made up of what? You implement abstract class, or not class, abstract methods. Okay, you specifically implement those abstract methods. That's what it's focused on. It's focused on doing something for anonymous inner class. Okay, and then you use anonymous inner class, in this case, also create an instance. And once you create an instance, then you can go ahead, use that instance is it to access its method. So this grade basically calls this, is it? And that grade someone calls the previous one. Okay, so this is the idea about anonymous inner class. Okay, and then we can run it, okay, to see what it looks like. Then did you see? It just output the different version of greetings. Okay. Okay, so this is regarding anonymous class. We kind of also understand, is it? Okay, then the next example is about that movable. Okay. So the next important concept is also very useful. It's in this example in our class website. Okay, Java Lambda expression example 3. Okay, so there are 3 files involved: movable, wandering, and Java Lambda ex3.java. Okay, 3 files. Okay, then let's take a look. So first, let's take a look. Oh, I need to. I need to close this. So first, let's take a look at movable. Okay, let's take a look. This movable is a very simple interface. It's a very simple interface. So it's just define one abstract method. It's just someone move to somewhere, is that basically who and where, is that move to somewhere. Okay, pretty straightforward for this one. Okay, then let's see the second class. So the second Java file is called wandering. So this is a class. Okay, so what this class, it has a single method called wander. And what this method does, it has 3 arguments, 3 parameters, 2 string, and the third one is that interface. So this is fine. I don't know why I cannot write. So parameter type is an interface. That is fine. And then you work on this interface, MV dot. That interface has a method called move to someone. Then you plug in who and where to this method. So this is fine. Even though that method is not implemented yet. Okay, but this is allowed. Okay, and then let's take a look. This lambda. Then over here, let's see. Okay, for the first one, we call it animal one. The type is what? Is that movable interface. After it, this is kind of weird, is it? We never saw this kind of statement. So this statement, it starts with parentheses, and within parentheses, you have argument. You have two argument kind, is it? Then you have this arrow. Is it? After arrow, it's just some statements. Over here is just a single statement. Is it a single statement? So what is this? Is it? Basically, this is called what? This is called lambda expression. Okay, lambda expression. But then just think about that movable interface. That movable interface has, let's go back, okay, to take a look at that movable interface. If we go back this movable interface has a single abstract method called move to someone. And this single abstract method has two parameters of type string. The type string. Okay, so this interface, basically we say it is a SAM interface. What is SAM mean? SAM interface means it has only a single abstract method. Then this kind of interface, we call it a SAM interface. Or more professional, it's called functional interface. Okay, so this is a functional interface because it has only one abstract method. But of course, you can still have default methods. Okay, you can have more. You can also have static method. Okay, those are allowed to have more than one. Okay, it's just the abstract method, you can only have one. The one that's not implemented, you can only have one. Okay, but anyway, so this has a single abstract method, and that method has two parameters. Is it? Okay, so this animal one, its type is called that movable. So it's something related with that movable interface. And this who and where, basically it's matches. Is it? It matches what? It matches it matches so matches that abstract method. Move to somewhere. Is it because it has who and where? Is it? It matches that. So basically, this part is the implementation of this move to somewhere. Okay, so basically this is equivalent to you write as move. So void and also public, is it to somewhere, and string who and string where. And you do this system dot out dot print line, and then you write who plus some roaming at plus where. Is it? It's just over here. We kind of cross out the type. Is it? And also we replace this part with this arrow. Is it? With this arrow. And when do we need to implement this method? As if you define a concrete class. Is it? Or an anonymous class. Is it? So basically, this is also equivalent to you define as like public. So some class, then it implements movable. Is it? It has some other instance variable or something. Is it? It's basically equivalent to this part, but this part we also don't have it. Is it? If you recall, anonymous class. Is it? For that anonymous class is what? Is you just do that new movable. Is it new movable? Okay, then curly brackets. But we also even script out of those. Is it? We just leave this single abstract methods arguments and its implementation. We just keep those part. Why we can do this? Because for this movable interface, that's the only method that whenever you define a concrete class or an anonymous class, you need to implement it. The compiler will know, basically, this is the implementation of that single abstract method. So we basically just script out of those repetitive definition. Is it? So this kind of idea, we call it Lambda expression. Okay, so this is a very trendy way for programming. Okay, so for functional interface. And the functional, why we say it's fun? Because that's all you care about, that single abstract method. Is it? And you care about only its implementation. And our lambda expression, if you recall, it's just to focus on the implementation. Okay, so basically it's kind of you just implement this method, but all of this, it's equivalent to what? To you define a concrete class, and as well you create an instance of it. Okay, so basically this is more simple than anonymous inner class, is it? We already see, because the very traditional way is you create a concrete class that's either extends a superclass or implements the interface. Is it? That's for, and then you use it to create an instance of it. Then you can start to call its methods. Is it? Over here, we kind of combine all of them and just focus on that single abstract method implementation. So this is called a lambda expression. Basically, a lambda expression creates an instance of some unnamed class for you. Okay, create an unnamed instance of some class for you. So this is a lambda expression. Then for the second one, robot, is it? The type is movable, same thing here. We have a lambda expression. Okay, then if you recall that wandering, it is a class, concrete class, is it? So that's why you can call its constructor. Is it called its constructor? And if you recall that wander method, so let's take a look at that wander method. So that wander method, it's implemented, it call the abstract method. Is it move to somewhere regarding that interface? Is it? Okay, then over here, we call the wander. Is it? We call the wander, the first we plug in a string. Second, we plug in a string. Is it? The third one is what? Is lambda expression. And that lambda expression basically is what? It create an instance. Is it? Of some class. That class implements movable. Is it? So this animal one, the type matches. Is it? Matches. Okay, and what are going to be plugged in? It's this two. Is it? If you recall that wander method, Is it? Then this animal going to match who and prairie going to match where. Okay, so that's how you are going to then use the lambda expression. Okay. Okay, then this one for robot one, same thing. And for the third one, you see, we even simpler more, is it? So this time we even don't create any variable, is it? We directly plug in the lambda expression. So you can also directly plug in lambda expression as an argument for a Java method. That's also fine because anyway, this is going to create an instance. And that instance is some class that's going to implement movable. So it matches whatever defined for this wonder. Okay. And this instance is the type for the wonder method is movable, is it? And here we plug in with instance is some class without name, basically, is it? This is fine. This is regarding what we previously learned called polymorphism and dynamic binding, is it? So this is fine, okay. Okay, so that's all for the information, the new concept regarding regarding our anonymous class, inner class, and lambda expression. Okay,